So now we're going to talk about ionic bonding. What is ionic bonding? Well, we know in nature, nature, everything exists before things start to bond. From the periodic table, all the elements exist like hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. All these things are elements that exist. What happens? Um, elements bond together to form compounds. And when they bond, they form compounds like cars, trees, all these things around us. One way of bonding is ionic bonding, covalent bonding. And we're going to talk about ionic bonding. How does atoms bond ionically? Well, for ionic bonding, we will look at certain things. The periodic table and the atomic structure, how it relates to bonding. So with ionic bonding takes place between metals and non-metals. Anything past this staircase is a non-metal. All these are going to be metals. There are mostly more metals in the world than non-metals. That's how you remember. You go like this, non-metals. We're mostly metals. Gold is a metal. So it's over here. So you know this is metals. Oxygen is a kind of gas. So this is mostly here oxygen. Non-metals, metals. Right, so what we're going to do is put some charges on top of these and we can explain those charges over here. So when an atom bond in ionic bonding, what happens is let's take example. Well, ionic bonding takes place between let's take two atoms for now. Two different types of atoms. Right? So it happens, so let's take for example let's take sodium atom and chlorine atom. These form something called salt, normal salt, like you see when they bond. So when you have something like sodium, which is a metal, falls on the metal side, and chlorine, which is a non-metal, forms on the non-metal side of the graph, then they will bond ionically. That's how you know it's an ionic bond. So let's look at and why is the charge +1 and why is the charge for chlorine -1? -1 and you have +1. Well, let's look at the atom. This is a sodium atom, which is over here. Sodium on this side. And this is a chlorine atom. So, an atom by itself is neutral. It doesn't have a charge. By itself, it's neutral. They have the same amount of electrons and the same amount of protons. So here they have 11 protons, they have 11 electrons. Here they have 17 protons and 17 electrons. Right? They have the same amount of electron protons. When these two elements or two atoms come together and bond together, what happens is that, as we said, they try to create a stable shell. So if sodium loses one, it has the outer shell goes away and it becomes stable. Chlorine gains one because it's missing one here. If it gains one, it becomes stable. So that's what happens. This sodium atom goes, sodium proton electron goes here. But when it does that now, when the bonding takes place and the electron goes from here and it goes to chlorine atom, this atom now at that point has more protons because it loses electrons, so it becomes positively charged by 1. So the sodium atom has a +1 charge. If you look at the graph, sodium has a +1 charge when bonded with chlorine. So what would happen, so the reason why we put +1 there is because always, if you think about it, sodium will always lose 1. So in a bonding situation, sodium will eventually always create a 1 plus charge. Chlorine, on the other hand, has 7. Chlorine will always try to gain 1. So when bond takes place, chlorine would always try to get an extra electron. So chlorine would always try to become -1, negative charge. So if you look at chlorine, when it bonds, it would have a negative charge. So the negative and the positives show what would happen during bonding or after bonding, when bonding takes place. These are the charges that will emerge for each one. So what would happen is that, you see here, sodium would become positively charged, chlorine would become negatively charged. The both charges cancel each other. They would track each other now, right? So this is how we write it in symbol form. NaCl, the two coming together. When this happens, what happens, because it's bonding with charges, at this point now you have to try to neutralize the charges during bonding, because during bonding a sodium atom and a chlorine atom, for example, would bond with negative and positive charges. So you have negative, positive, negative, positive. They all bond them. They all attach themselves positive, negatively. So they could only stay together if they have the charges cancel out. Here charges cancel out. So it takes one sodium atom to create one chlorine atom. So the answer is the charges neutralize self. So you get NaCl. Okay, let's look at another example. Let's look at lithium wanting to bond with oxygen. How would they do that? Well, we look at the periodic table. We see that lithium is a metal. Oxygen is a non-metal, so that means that would bond covalent ionically, because ionic bonds take place between metals and non-metals, separated by this line. So we know that it would bond ionically. So what would happen is that we look at the charge. We don't have to draw the diagram. If we know what the charges mean from the last example. So we know that the charge is here +1. For lithium, it's going to be +1. This means that when bonding takes place, lithium would have a +1 charge. We can think about it as lithium having only, for lithium to have a +1, that means it must only have 1 electron in its outer shell, so it will lose that 1 electron, so it becomes +1 charge. But look at oxygen. Oxygen, when ionic bonding takes place, it gets a -2 charge. So that means it gains 2. So that means it's actually pulling, if you think about it logically, it's actually pulling 2 lithium atoms together to form that, right? Well, let's look at it more. Think about that as we go. So what happens is that lithium would have a charge of +1, and oxygen, well, look at oxygen. Oxygen has a charge of -2. So I put -2. Now all we have to do is neutralize the charges, means make the charges neutralize. So if you have just +1 but -2 oxygen, it's not gonna neutralize. It has to be the same. So in this case, what we do is we add another lithium atom, which has another +1 charge to it, and these 2 charges will cancel out these 2 charges, so you're left with lithium, 2 lithium to 1 oxygen. And it makes sense, because if lithium has to get a negative charge on the outer shell, if this is oxygen, if oxygen has to gain oxygen, this is lithium, so this is lithium. So if lithium gets a charge of, if lithium gets a charge of +1 after bonding, that means that lithium lost 1 electron. However, oxygen has a -2 charge, so that means oxygen gained 2, not just 1, but it gains 2 electrons. So where would these 2 electrons come from? They would come from an extra lithium. So that means it takes 2 lithiums atoms bonding together. They're coming together like this with 1 oxygen. So that's why the equation says lithium 2 oxygen. It takes 2 lithium for 1 oxygen.